Alright, welcome to the continuation of the rotation tutorial. We're going to look more closely at orbits. If you didn't catch the first part of the tutorial, then you have three choices. 1, go watch it. 2, go download the code from Pastebin. 3, none of the above. For the most part of this tutorial, although the most part of this tutorial is not Unity dependent, the orbits of the moons, or the orbits of an object that is around the object that is orbiting, will use the rigid bodies. That's something Unity provides. Unreal has some similar objects. This simply makes the orbiting possible. The moon orbiting around the planet. Also, I have a few textures, but you really don't need them. Just go find 3 or 4 textures, make some materials. That way you can tell your planets, your spheres, from planets to suns to moons, just to make it simpler to debug or to set your settings. So let's get going. This part of the tutorial is just implementing what we've already done in some different ways. Let's go to the editor folder and create a new script and call it OrbitLab Editor. Wonder what it's going to be for. Go down to the scripts and add a script called OrbitLab. Open one of them and open the other one. Go back and open the editor. However you want to do that. Okay, first of all, change your editor into an editor. Add the using tag for Unity editor. Grab the custom tag. Go ahead and put our stub up here, our member variable for the lab itself. Fumble fingers. Our lab is null, the lab will be equal to ToRadians of the target, and draw our default inspector. Add the on enable. Just copy that code once again so we're associated. Let's see here, let's grab, where is this? So that will allow us to select multiple orbit objects and assign all of their parents, or assign a certain property to all of them the same. Alright, jump over, save that, jump over to the OrbitLab itself. So, no, well, excuse me. First, we're going to the extensions lab. We have to add some new math methods. Now, a lot of these methods you could go to Unity's default objects, Unity's child properties off the shared mesh, get the mesh filter, get the shared mesh, get the bounding box, and we can get a lot of these properties. You could go ahead and do the calculation from those values. I went ahead and added this, something you can use in your own personal projects, and it's something I use quite often. Generally, these are pretty self-explanatory. I'm getting the maximum X of the mesh, the maximum Y, the maximum Z, then the minimum of each value. And from those, I'm calculating the width, the depth, and the height. And I'm calculating the centers. The code will be posted to Pastebin, so no worries there if I'm scrolling too fast for you, which I'm sure I am. So let's jump back to our OrbitLab itself. We have some property values to get in here, or some member variables to get in here. Leave the start and the update for this lab. We are going to run it, so we will need them. So we have 3 rotations this time. We have an initial rotation that takes place one time. It will take place in the start. We have a rotation around our objects sphere, our objects axis, which will be our spheres because they're planets. And then we have the orbital rotation. This is how much it rotates around its parent. Now for this, we will be using Unity's rigid body. It will be a little bit Unity specific, but Unreal has equivalent items. We need our create face first, create axis this time instead of create face. And we will have to call the create axis every time we move our object. So we'll do that from a create function like our other lab. And here we can turn the run and edit mode to true when we click the create button, and that will make our sphere rotate. It will not run the start, but it will run the update. So that's pretty cool. We can see our sphere. It's very jumpy though when you do it this way. It's not smooth like it is in run mode. So here we're drawing our axes exactly as we done in the last lab. Now we're going to bring in the code that has changed from the last lab. So this code did get a little bit different. First of all, let's add our Unity. This time we are actually recording, we're actually rotating the sphere itself and not rotating the vectors. We're rotating the game object, the transform of the game object. So we're taking the Euler angles. This is a rotate Z, so we have to take the current Z rotation and add it to the Z rotation that we want to rotate it. And this will rotate it around its center point. Yeah. Here, like before, we're just doing our prepare Z and our prepare revert Z. They both should be identical to our previous versions. And now when we go up to our rotate centers though, they're a little different. We're taking, instead of that axis point, instead of taking the anchor we're rotating around, we're using the parent's game object, which would be our sun, except for the sun. For the sun, the parent game object will be another game object where we can add some wobble to the sun, but we're taking the parent game object's transform in local position. The logic behind that is if the sun is a child object or something else, all of our planets are also going to be child objects of that something else. Although our planets will not be child objects of our sun, our moons will be child objects of our planets. So it's a little tricky. And as I said, you can do a lot of this with Unity's built-in components. I like this better though because I can make it smoother, I can make it crazy, I can make it more random and make it a little bit more real. Unity's is too static for me when you're using just the joints. So in the update function, we're going to call all of our rotates if they have a value. So if our orbit has x orbit has a value, then we rotate it. If our x rotation has a value, then we rotate it. And now in our start menu, the only thing we do is the initials. Initial x has a value, we do that initial rotation so we can give our plane a little bit of tilt. We don't want to constantly give it that tilt. Once we give it that tilt one time, it will forever have that tilt. That's thanks to the way we're doing the Euler angles down here. Now let's jump over to our editor and add a button in lab.create. All right, let's go back to Unity. Let's add a sun. I have some materials here that I found or I created. It's a sun, some planets. Don't worry about copying this. You can just get any. These aren't that fabulous. They're just very quick, couple minutes with Genetica. I mean, seriously, my sun looks like a planet that just has some really weird colors. So just go to Genetica. I mean, go to on the web and find some different colors for your planets and your sun and your moon. It makes everything easy to see. Now we need, there's our sun. We need a parent for our sun. And that will be just an empty game object. Sun's parent. That's a easy term. All right, so our sun, let's give it some default values. Its initial rotation, its initial orbit is very, very small. It will have, or its orbit is very small. Its initial angles are 0.15 and 0.15, and we'll give it a y rotation of 1. That's the rotation they'll have while it's spinning on its axis. And the sun parent, we can move that around while we're running it. Let's go ahead and and I forgot to do what I said. Click the create button, and now we see our axes. Someone asked me, do you really pronounce plural axes? That's the way I've always heard it. All right, and there's our sun. It's just rotating out there. You got to see it's on its angle. It's kind of loping there. It's good. So it kind of looks crooked, but it's not. So let's give it a little bit more angle just to see what that looks like. I think I should go split window. And there we go. Our planets can rotate around it. Okay, let's add a planet. Not a game object, a sphere. Planet 1. Really? Planet 1. They must have got added. Let's give it a little bit of scale. Move it about, I don't know. I said give it a little bit of scale. Move it about right there. It's kind of Earth. Planet 1, Planet 0 actually, I think is what I used. Yeah, Planet 0. Add an OrbitLab and then add a rigid body. Okay, Planet 0, it has a Y rotation of 1. It has gave it a negative inner Y rot, and I gave it a negative initial rotation. So we also need to tell it that it belongs to the sun, and we need to create it so we can see the axes. Yeah, I think I already done that. And wow, there we go. Our planet, it has a really steep orbit, but it is orbiting the Y of the planet, of the sun. I mean, it is crazy steep though. I don't know what that would cause. Okay, there's planet number 1. Let's make it bigger. Too big. Can't be bigger than our sun. Alright, and let's drag it a little bit farther away. And click the create button again. Okay, let's do another planet. Planet 1. Once again, add a rigid body and add a OrbitLab. Okay, and this one has a Y orbit of 0.25, just really small. It has a Y rotation of 1, and it only has an initial Z of -15, and its parent is also the sun. Now see, the multi-select allows us to, we could change any of these values to the same value on each of them. Can add multiple objects. If you don't have that on there, it will complain. You'll see cannot add multiple objects. You won't see this when you have multiple objects of the same type selected. Okay, so where is our little new planet? There it is. Let's see, what size is our this? Okay, so we'll make this planet 5, 5, 5, and let's lift it up a little bit. We don't want the exact same orbit as our, though let's take it down a little bit. And what does that look like? Forgot to click create again. So it's rotating a horrible rotation. But it is actually rotating around the sun. It's just the view, the angle we're at right now. Speed it up a little bit and give it just a little bit more Y rotation. I want to raise it up a little bit too. Let's see here, just a little. There we go. I like that better. I guess it's not scientifically correct, but I don't care. Slow as molasses. Okay. Yeah, let's go ahead and raise it up a little faster than that, 0.75, and give it an initial rotation of 30. See how that looks. Wow. Okay, I like that. My planets are going to collide and blow up the universe, but yeah, that's part of it. We'll raise it up even more just to see. Alright, there we go. There we go. Our planets are totally carrying their gravities, totally pulling on the sun in different directions. It's just going to blow up and explode. Wipe everything from existence. Okay, and now let's try a moon. Moons are really annoying. This is where Unity stuff really comes in handy. You can try to use the joints. You can try to just different techniques to tether the moon to the planet. But overall, it really doesn't want to be with the planet. Okay, our Y rotation on the moon is 0.001, very small. Our Y rot is -5. It took me a long time to get some values that really worked, so you got to mess with this. the moon, the planet 1 is the parent of the moon, and then the moon should be childed to planet 1. Let's see here. And let's just drag the moon over close to there and create. Next of all, let's give the moon some kind of color, and I didn't put your texture on you. Okay, so let's see how that's going to work. Oh, it's nowhere near his planet. That would have been crazy orbit. It's really little. Let's make it a little bit bigger. Yeah, that's too big. It's almost the size of the planet. Alright. Oh, wow. I forgot to click create. And they all have some rigid bodies. And now the moon's chasing it from this point of view. Let's see here. Wow. Well, it's going underneath it, so we can speed our moon up a little bit, but it will shoot off into nowhere. So at the overhead view, it doesn't look that good, but on this view, it actually looks like it's doing what it's supposed to. We can give it a negative value, but sometimes it will just shoot off into space if we give it a very high value. Like if I go boom, there it goes, it's going off, it's rotating, it's still rotating around the Y. Or yeah, it's still rotating, but it's kind of lobbing. So it's tearing our planet apart here. We can give it a higher rotation. There we go, higher initial rotation. Wow, it's not even finishing the orbit. It's doing its orbit, but it's just kind of lobbing on top of it from the side view, from the top view. Let's raise that up and see how bad that's going to be. Okay, there we go. Oh wow, it's just like ripping the side of this planet apart. There it goes. It takes a no. Let's turn that back down then to -15, like the Y rotation. Yeah, it's totally on that one side of it. Give it a 1. It's outrunning our planet's orbit is basically what's going on. So we have to slow it down a little bit so the planet can beat it. And of course I am doing it negative here. Let's do it back to positive. At least it was finishing then. Try 0.01 forward. Now it's orbiting the same way as the planet. There it goes. Well, no, not quite. Now it's spinning like crazy. There, yeah, almost. I also think we need to and that's just too fast. So the moon you gotta mess with. You can get it to work though. Mess with it. So you can try the joints. That's a good way to work with it. Put a high angular drag on it and see what happens. There's no really gravity in this case. There he goes. It is now really crazy wide orbit. I guess our planet should be more like, our moon is currently half of it, so our planet should be, maybe should be 10, and then our moon should be still really small. Okay, now I think we could make that work. Moon's going super fast. So the moon's values are really small. I like how the orbit kind of gets closer whenever we get there, depending on how the sun's where its position to the sun is. Now, let's mess with the whole world a little bit here, and let's drag the sun parent, way over there. Increase the sun's. Give it a little bit of a wobble. Come on, give me that wobble again. All right, that's too much. That's a bounce. And the planets are kind of going crazy here. Yeah, the moon's just totally off. So you can mess with this for a long time. It's fun to watch how everything's affecting everything. Alright, we just lost our planets, I think. They've shot off into an Outer Limits episode, or a Twilight Zone episode. They're off into space. They've been shot away from the sun. Except for this one. And we've kind of burned it black. So that's pretty much it. I will post this code to Pastebin, and I'll put the link on YouTube. I hope to have some more tutorials posted soon. So God bless.